Okay, looking at the domain and range, whenever you find the domain and range, the best way to look at it is probably to look at the sketch of it. So the hyperbola basically looks like this. It's asymptotes. They're the lines that the curve gets closer and closer to but never actually cut. So one of them's the x-axis and the other one's the y-axis. So x equals 0 is one asymptote, y equals 0 is another. So when you're getting the domain is all real x except x equals 0. And you could also write that as, if you want to write it in that interval notation stuff, be minus infinity to 0 and then 0 to infinity. The range would be all real y or except y equals 0. Except y equals 0. And if you write it with the infinity, it's the same thing. Minus infinity to 0, 0 to infinity. Okay, so let's just look at question 2, this one. So we've got y equals 1 on x minus 2. Okay, so when you sketch that is shift to the right 2. It's horizontal shift because x minus 2, like that's inside the function. So instead of being at 0, it'll now move to 2. So that forms a new asymptote. So when you're looking at the asymptote of this graph, the asymptote would be x equals 2, and the y asymptote would be y equals 0. So that still stays the same. Do you notice that the denominator, so x minus 2, cannot equal 0, not equal 2, because 2 minus 2 on the denominator would be undefined, be 0. Okay, so that's these here, they are the equations of your asymptotes. Okay, and your basic curve, because it is a positive hyperbola, would look like that. And if you put in x equals 0, you get y equals 1 over 0 minus 2, which is minus a half. So when you're writing the domain, it's actually all of the x except x equals 2, because that's your asymptote. So if you did it in interval notation, it's minus infinity to 2, and you can do it either way. You can write as all real x except x equals 2, or you can write it using the interval notation. So the range is all real y except y equals 0, because that's your asymptote. You could go minus infinity to 0 and 0 to infinity. Okay, and let's just look at the third one. The third one was y equals 1 on x plus 1 minus 1. Okay, as far as looking at shifting here, that would be the plus 1 that's inside the function. That would be shift to the left. So that would be a shift to the left by 1. And this one here, this is a shift down, because that's a vertical shift. So this one's the vertical, and this one's the horizontal. Okay, so if you shift to the left, minus 1, and the vertical is shift down to minus 1. Okay, so that means that this would be here and here. Okay, so if you put in x equals 0, you get y equals 1 over 0 plus 1 minus 1. So y equals 1 minus 1, which is 0. And if you look at that now, the asymptotes, the equation of the asymptotes are basically x equals 1 and y equals minus 1. And then the domain will be all real x except x cannot equal minus 1. Because if you got 1 over x can't equal 1, sorry. If you got 1 over x minus 1, if you put a 1 in there for the x, you'll end up with 0 on the denominator. That's why x cannot equal 1. And the range, well, the range is all real y except the asymptote. So except y equals minus 1. So y, so except x, this should be except x equals 1. Which really x can't equal minus 1. Y can't equal minus 1 either. You could also write these in interval notation. So it's minus infinity to 1. And then 1 to infinity for the domain and the range. Minus infinity to minus 1. And minus 1 to infinity for the range. So if you look at this here then, you got minus 1, as that's where the x can't equal, and you've got y. I've got minus, should I have minus 1? That should be 1. Yeah, no, it is minus 1. I think all that I did was I rewrote this one. I rewrote that one as plus 1. So when you do the asymptote, x is minus 1, and that means x can't equal minus 1. So the domain will be minus 1 as well as the y is a minus 1. Sorry, my mistake there. So x can't equal minus 1. So it's going to be all x except that. Minus infinity to minus 1 and minus 1 to infinity. And the y value, x can't equal minus 1 either.